Valentin, I have the link. Should I just send it to you or?
I got it, yeah.
Okay, cool. I think it wasn't online yet.
Mm-hmm. By the way, it's Corona time internet, so if I suddenly break, I will reconnect from my phone. Just wait for me.
Okay, cool. Let's see how it goes. Should we wait a couple of minutes to see if more people come? Oh, and then we can slowly start.
So let's start.
Yeah, sounds good. So I will start recording. Hello, everyone. Welcome to the first session of Introduction to Algorithmic Literacy by Valentin Golev. Valentin Golev is a programmer and theorist of technology. He is currently completing his certificate at the New Center for Research and Practice, and he investigates the representation of science in art, particularly in the post-Soviet computer games and video works. I'm just gonna brief the course outline that's also available on the website. The division of cognitive labor, which starts with the two-way ideological isolation of the STEMs at schools, is an attack on our collective capacity to read. What is getting lost is the medieval multiplicity of readings of a recipe, as an alchemical instruction, an ethical injunction, or an allegory, with different casts of people being able to engage with the same text in a different way. Learning to properly read the technology is the first and necessary step to any usage or critique of it. Algorithms are rarely engaged with as pure works of writing. At the same time, the algorithmic writing rewrites the world. Even the very words appropriated by the algorithms find themselves commonly used in the same restricted or amended way. The limitations that algorithmic thinking imposes on the world are acquired, naturalized, and shaped by the society as a whole. In this seminar, we will learn how to read algorithms on a variety of levels, from the source code to the typical format of input, from the history of an algorithm's discovery to the peculiar marks it leaves on the output, from the cognitive economy of labor that the programmers perform to realize it, to the infrastructure necessary for its operation at scale. We'll learn how to understand and recognize an algorithm. We'll engage with the fundamental algorithms little known outside of the tech world, as well as the ones that are currently in vogue. This seminar seminar will not try to impose any particular philosophy or of computation, or even to explore their variety. Rather than that, it focuses on particular technological artifacts, ethnography, archives, and anecdote. The cultural research around particular algorithms is little to not existent, and we'll have to reconstruct the multi-sided overview ourselves. So now I'm gonna pass the mic to Valentin. Thank you.
Hello, everyone. I'm Valentin, Valentin Golev. Yes, I've been working in this industry of computer technology for more than a dozen years. And as I was moving from purely technical roles to more managerial roles, or like things like business consulting and starting my own companies, and also as I was studying philosophy and as my political views have been maturing, I wanted to look for ways to reconcile this kind of political commitments of mine with my practice. And I was looking for ways to talk about technology and criticize technology in such a way that it would be at the same time progressive and critical, but also productive. And so this seminar in particular is my experiment in trying to understand how this kind of critical evolution of a field can proceed. How can we talk about things like engineering? How can we understand them in such a way that on the one hand, our conversation continues to be productive and meaningful for practitioners, but at the same time, it would be socially ambitious and not reductive, and kind of trying to see all kind of sides and aspects of what technology is. So let me put slides on. Okay, so goals of our seminar is, as Sebastian already read, to consider computer technology in the variety of contexts and to explore, the material conditions, economic structures, and labor relationships that govern it. But at the same time, I don't want to reduce everything to this kind of Marxist view of the world, and I want to look also for what seems to be exceptions from all of them, and to kind of find ways to talk about everything in its own terms, rather than in some kind of externally imposed view. I also want to help you by teaching you some practical concepts for understanding particular kinds of technology, so that when you engage with it, you know what kind of questions to ask and what things are actually meaningful, and how practitioners themselves view all of those. You only see blank screen? All good?
No, there's a slide.
Okay. Yes. So my goal is, since I cannot teach you, I don't want to teach you programming, and I don't want to teach you everything about technology. I rather want you to introduce you to the kind of mindset, engineering mindset. And to understand this mindset, one has to understand what kind of relation engineering stands to other kinds of labor, because every kind of thing, every kind of thinking is defined by material conditions that enable and test it. Just to give you an example, if you're talking about, artificial intelligence with an engineer, maybe in a bar, he will talk to you about it and exchange some utopian or dystopian ideas. Or when an engineer talks to an investor with a capitalist about artificial intelligence, he will also be able to talk about this in a meaningful way. But when an engineer sits down to work, this is not a concept that can exist in his work. And it's not a concept that can exist in his work, not because it does not exist in some kind of philosophical sense. It is just a concept that doesn't fit into a labor structure of engineering. It just doesn't make any sense for what the actually engineering practice is. So that's the kind of thing I want to talk about, and this is specifically what we're going to talk about today when we explore idea of automation of labor. So automation of labor clearly stands in a particular relationship to labor. And I want to also say a little bit more about my own goal of this seminar, even if you don't share it. And as I said, I'm really interested in some kind of a really good, practical, meaningful critique of the field. You see, I believe that it's absolutely of no use to tell an engineer or a doctor or an architect that people, for example, people who pay him or her are wealth criminals, or that whatever he's building is going to be used for neoliberalism, or that whatever he builds is going to use alienated labor. I mean, it's clear, it's true in all cases, but it's not a useful critique. I think real critique introduces new concept to the practical language, and I think real critique introduces new ways of thinking about practice that highlight kind of from the inside things that can be used for progressive goals. And one particular concept which now is being slowly introduced into as a whole engineering field is actually concept of labor, which was very curiously almost absent in a serious way from literature on computer science, artificial intelligence, or any other engineering disciplines. And now, by work of Kate Crawford and Matteo Paschinelli and other good people, it's been introduced in the engineering, not just as a way to criticize programming as a whole, but to highlight things that happen that engineers have to see, must see, and that seeing them will enable new possibilities for engineering practice. So for us to be able to see what kind of conceptual critique can have this kind of impact, we have to kind of understand how this labor works, how this language works. And that is, I think, for us, is the only way to meaningfully and critically engage with engineering, because even if the most glorious revolution comes and suddenly end up being in a complete communism, all of these things like engineering and architecture and everything else, they will not go away. People will continue doing them. And the history of each of those fields, most of them are quite longer than has been existing quite longer than programming, shows that any kind of change in political situation influences the tradition of a field, but it doesn't abruptly change or break it. And every kind of architect, when he's practicing his craft, he's referring to the whole history of architecture, including architecture that was not clearly, ideologically or politically on the same terms as him. So I'm looking for this kind of engineering self-critique, or our as philosophers possibility to influence it in a productive way. And I think we can have it both ways. I think we can have a good critique and productive practice afterwards. Okay, so a little bit about this course. So I think it's 8 sessions.
Yeah, 8.
Yeah, we have a syllabus, but I think, if it ends up being a little bit overwhelming, which I think it will not be, because it's in the end, it will feel like, English or philological seminar, I think, in many ways. I think we can cut it a little bit and take it a little bit slowly. So don't worry if you feel that you want to go a little bit slower. Definitely use QAA time for that to make all these kind of comments. For people who take this seminar for credit, there's going to be assignment in the end, and I'm thinking, there is a usual essay form, so you can write an essay, but you can also do any kind of media art in a very general sense project that will be somehow inspired or interacting with what we're going to talk about, and you can use any kind of medium. You can use digital programming, anything, or you can use your own medium if you know how to express some kind of something that you learn. Like the only hard requirement here I have is that I don't want to look at it and feel that it was a complete waste of time for you. So that's the assignment, right? But if in the end you like the backup plan, always just write a good essay. Okay. So today we're going to talk about automation, abstraction, and labor of engineer. I think there is quite a lot of material for today. So let's have a Q&A moments in strategic point, and which you can also use to make some kind of general comment as well. If we have time in the end, we will do a little round of introductions, and because I want to hear what your experience is and what you expect from this seminar. But we will see. Let's start with the actual lecture. Okay. So first section is called Economics and Languages of Automation. And what it actually is some kind of realist and partly Marxist interpretation of a game Universal Paperclips, which I asked you to play before this session, but obviously it's the first session, so I maybe didn't. Still, it's a really fascinating game, and I think it deserves a good interpretation. It's not going to be a total economic theory of automation, in the real world, but with what we're going to do is going to help us explore relationship between time, labor, automation, and language. That just like kind of defines a conceptual field here. And there is going to be a little bit of mathematics. Now, I was asked many times how complicated and hard this course will be. And I just want to say it's, I know there is a lot of people who just space out the moment we see some kind of mathematical things. So I ask you not to do that because it's not going to be a lot. It's going to be very, very clear stuff, in my opinion. And if you actually understand, the simple maths that I'm going to talk about, maybe you will see this drama between engineering innovation and automation and capital that is gonna just being played out here, because it's a really, I think it's quite dramatic. I'm not sure if I will be able to convey, the whole passion and tragedy of it, but I mean, I think it's going to be, unlike many other users of maths, it's going to be actually a rewarding experience for understanding like history and conceptual situation of a field. Okay, so as I said, we're going to use a game called Universal Paperclips, made by Frank Lantz in 2017, and it is a really great game about automation. It doesn't just tell you about automation, it actually shows the effect of automation on you, on the subject, because it actually creates this cybernetic loop. It creates in you, at least tries to create in you this kind of desire for more and more automation. Now, if you Google it, if you go on Wikipedia, you will learn that this game is about artificial intelligence and Nick Bostrom's anti-utopia. But I think, my kind of interpretational motto here is that every horror story about AI that we hear now is a real story about contemporary economy of technology. Every time we hear about like some kind of dystopia about extreme exploitation of labor by artificial intelligence, it's actually already going on somewhere. And the same here. So I don't think we should even mention anything about AI when we look at it, because the game is actually about very simple automation. And those paper clips that that the name refers to, and that are the main resource in this game, I think it's an unconscious Adam Smith reference. In the very beginning of The Wealth of Nation, Adam Smith tries to defend, tries to sell to everyone this concept of division of labor, in which we can actually recognize more of an abstraction of labor. He's talking about making pins, right? So it's not paper clips, it's pins, very similar thing in a way. And he's talking about how by dividing this labor of making a pin into small parts, like you have to cut the wire, you have to make a head of the pin, you have to bend it, you have to paint it, you have to package it. Like there's always little steps. And he says, if all the labor is divided into those steps, and there are people who really specialize into one particular kind of labor, they will be able to do it quickly, efficiently, and the whole operation is gonna be just very, very profitable. And I think it's kind of a gloomy image when he's in such an excited way talking about this person who makes legs of a pin for all his lives for like 40 years and gets really, really efficient. And obviously this kind of approach to labor is one of the main targets of Marx's critique when he criticized what he calls abstract labor. Okay, so let's see. Let's look at this game. It actually starts pretty simple. That you just have a number of paper clips that you have, and you have a button, make paperclip, and then you can also sell them. Now you click and click and click on this button, and you kind of feel like this worker who is condemned to make paperclips all his life, until suddenly a new button is there called autoclippers. Autoclippers is a way to automate making paperclips. So basically, instead of clicking the button to make a paperclip, you click a button to make a machine that will make paperclips for you with some kind of a constant speed. It just churns out paperclips for you. But with clicking, again, it actually feels the same at some point, because you just click and click and click on this autoclippers button. And of course, production speeds up, but it's still not fast enough. So at some point, new things are getting introduced. There's new weird buttons, weird ways to speed up the whole process. And like things like strategic modeling, photonic chips, theory of mind, all of this is being developed to speed up this production of paperclips more and more and more. Okay, yes, and it ends like this. I think this is like one of the last screens. You have like absolutely insane things going on. You don't like, there is still a button to make paperclip, but unimaginable things happen, and still it's all about really quickly making and using paperclips. Okay, so let's see what happens here, in some kind of economic terms. So when we're making paperclips by hand, like our labor, abstract labor, has predictable and linear relationship to production. We click 10 times, we get 10 paperclips. We click 20 times, we get 20 paperclips. If we click for 1 hour, or for 4 hours, we will get 4 times more paper clips than we could get in 1 hour. And that's kind of what's one of the most appealing things for a capitalist in abstract labor, because it means that you have very predictable relationship to production. You can predict things, you can replace worker by somebody else who will do the same amount of man hours. And it's good, it's manageable, and it's just like the line goes burr, right? However, when we have auto clippers, a different thing happens, right? So before we were making paper clips one after another by clicking this button, but now in the same way, by clicking a button, we create auto clippers. So again, with time, we have more and more and more auto clippers, and it's a linear relationship. But since we are growing not just amount of paper clips, but we grow in the speed of producing them, the actual number of paper clips grows not in a linear way, but in this quadratic way. You see, it's just faster. Then after we automated a little bit more, we get like even our auto clippers power grows faster than linearly, and then our paper clips amount grows even faster. You see from those numbers how drastic the acceleration is. So if that is clear, let us see what happens when labor is being automated. And I think what this game considers is a really, really complete and drastic automation of labor. It's not just about producing paper clips 10% quicker. It talks about every step of the way we get almost perfect automation. So what I mean is that a completely automated labor looks like a machine that just constantly produces things with a particular speed. A perfectly automated maker of paper clips is just a machine that prints them. And it's not just speed up, it just goes. And in this way, the old labor of making paper clips by hand loses value and even is abolished, because nobody needs to make them by hand anymore. They just print it. However, there is a new kind of labor that is about creation and operation of such a machine. Making such a machine is also labor, and now somebody has to manually assemble such a machine. And since I posited that abstract labor has a linear, like produces something in a linear fashion, right? Like this. What is being increased here? It's speed of production, right? So we increased amount of paper clips. Now we're increasing speed of production of paper clips, and it's bound to be much faster and become really fast really soon, because even if assembling of such a machine is much slower, after you assembled enough of them, you outpace any kind of manual labor very quickly. So this new form of labor is created. Instead of the old kind of manual abstract labor, new form of labor is created that has new structure and new conceptual language. Because language that a paperclip maker uses to describe his work, like what is it? He has wire, he bends it, he puts it somewhere. It's already exhausted in his labor, so a new machine will have a little bit different language. It will have new, more abstract terms. For example, one way with such automation can go is that if I just make paper clips at home, I buy a piece of wire myself, so I have a concept idea of a wire. But if I have a really automated production of paper clips, just a piece of wire is not enough. I have a constant supply of wire. So we have this new concept of supply of wire as a kind of constant flow of wire into my production facility that abstracts from this particular one piece of wire. And then down the line, when even supply of wire is not enough for me, because any one particular supplier is, will be exhausted or will have some problems, I can introduce even more abstract term of marketplace of wire, right? Where everyone can participate and supply wire to me. And in this way, I will get like cheaper prices for wire. I will get more competition. I will get choice and quality of wire. And I get, and it all is encapsulated in this one term, marketplace of wire, which is an abstraction in a way over a term of supply of wire. Let me stop here and ask you if it makes sense to you and you have questions. Okay. I take it as everything is fine so far. Good. So this particular game, Universal Paperclips, shows this process by creating a new kind of mini game every time there is an abstraction. Thank you, Artemis. So you see, like, imagine being an engineer who's doing this, and then at some point you hear and you automated it a little bit, and you discovered photonic chips and auto tuning, right? And all of those things, and you're excited because you have a new kind of, it's we can say mini game because it's a game, but you have a new field, you have a new kind of activity, you have a new cool set of engineering concept that like a whole new language to learn, to understand, and to automate. But at the same time, from perspective of capital, you just get this faster and faster growing lines, which are actually quite predictable and have a very predictable and sensible structure. So with the kind of funny things happens here that capital sees all of these things in a very different way. If no serious capitalist, no serious investor is hunting for some kind of cool new technology, because they all know that there is no super cool new technology. He can, like, now maybe they hunt for like super cool new commodity or something like that. But this idea of innovation bringing absolutely incredible and unthinkable things is not really part of this kind of economic process, because everyone is so used to it that they can kind of ignore it. And at the same time, from engineering perspective, every time there is a whole new activity, it's very, very different every time, and you cannot really abstract away from it completely. Because all of those, invention of a new idiom is, it's not clear, it's not very easily generalizable. We will look at it slightly later, right? But all of those mini games, all of those new languages of automation that get created in such a way, they're actually quite new. They're actually quite different. If you look at history of processors, for example, like every few years they invent some kind of crazy new technology, which is fascinating. But at the same time, we all know what they actually mean. They actually means that processors just go twice faster again. All right. Yeah. So as I said, this kind of innovation, it's not. It's kind of hard to imagine how exactly the next step of abstraction will look like. But with progression, it actually looks like something we can actually predict and see. We actually look at this and we see where this is going, like to higher and higher powers of x and further and further derivatives. And if you look at so this operation where you go from a function, some kind of dependency, like linear dependency, to a speed of change of the function is called differentiation. It's called taking derivative. You know it. I mean, it's high school. And if you want to see what is kind of the limit of this process, what is at the end of it, or what is in the most general way to look at it, we have to look at, for a function that would, like the differentiation of such a function would just bring it back to us again, some kind of thing that you cannot really seriously speed up, because when you automate it, it's just the same thing. And this function is called exponent. And I think this is kind of a explanation and of where Moore's law comes from. You probably heard of Moore's law, that it's actually about like number of transistors. Like nobody cares. Let's talk about generalized Moore's law right now. I mean, we will talk about this in a different session, but here, everyone in this field of like economy of engineering, they use Moore's law pretty freely. To me, like in a very, very different context, because you know, whatever kind of quantifiable way of quantifying, you know, automation you have, you can say that it will grow exponentially. You know, technological power just grows exponentially. Computers get faster in a very predictable, with a very predictable speed. Yeah, so I think, you know, kind of mathematical explanation of this is that with exponent, its derivative, its speed of change is also the same exponent. And you can also, you know, if you want to read Machine's fragment, I mean, Marx had really a thing for derivatives, for differentiation. He had a lot of ambition around it. He wanted to prove philosophically differentiation in some kind of way that he thought would be better than mathematics contemporary to him. He didn't really succeed, but unfortunately, at least in machine fragment, he does not apply his knowledge of it. Still, if you want to go kind of dig mathematically deeper, you can see, you know, you can look at this formula and see how it's a total sum of fixed capital, which will inevitably grow exponentially over time. So we have this kind of total growth, exponential growth, which is when you automate it, you get the same thing. What does it mean? We can look at kind of two sides of story here. Right? So one of them is kind of deterministic side of story, that we know that innovative growth is reliably predictable. When people in engineering say reliably, they mean that a lot of people use it. You know, it's synonym for engineering. There is no way to prove that something is reliable. You can only make sure enough people use it that it would break soon enough. This is how engineering talks about like security and a lot of other stuff, and networks and databases. And this kind of Moore's law, it's used in a lot of arguments and a lot of kind of strategies. Moore himself is a co-founder of Intel, you know, the microprocessor company. And you know, Intel quite consciously bases their innovation schedule. They even have an innovation schedule based on kind of understanding that Moore's law will continue to work in one way or other, right? And every particular instance of Moore's law, you know, has an expiration period, because you can only like make things that smaller. or faster, but in a kind of very, very general sense, there is always a way to, speed everything up or add more stuff. Companies, not only Intel, use this kind of expectations of growth even before they actually have any idea what kind of science or technology is going to be used for it. Also, it's used in evaluation of cryptographic primitives. Basically, for every kind of password stored in a particular way, you can more or less predict in which year people will be able to easily crack it. And that's how, NSA or any kind of security firm will base their recommendation of what kind of things to use. So again, like Moore's law here is important. Like Bitcoin, I think the paper mentions Moore's law. I'm not sure, but the whole idea of how value of Bitcoin will evolve over time is based on Moore's law in a very serious way. Like it's the value of currency is directly tied to this exponential curve. So we see there is a lot of drama, there is sometimes you watch like a movie or a TV show about like engineers and they talk about some kind of particular fancy technology, but actually all this drama is all for very foreseeable results. And to make sure those results happen, there is even a Moore's second law about like capital expenditure you need to make this kind of advanced steps. So there is like the whole field of automation is very much predictable. However, I think there is also a materialist side of story, which is very important, but not such a prominent thing in the conversation. That we have this exponential curve. It's very fast, but it's still not instant. There's still never a moment where you just snap your fingers and everything is fully automated, right? There's always something that just can't be done away with. There's always some kind of things that actually take time. There is some kind of labor that cannot be completely abstracted and automated, or at least for some time. So what we see is that, there is a speeding up, but it does not abolish time completely. It has actually a very different relationship with time. We'll talk about it a little bit later. Okay, no, we will talk about it now. Okay, maybe questions? No? Good. Okay, labor and experience of time. So one thing why I really, really like this game is that it makes you experience the time. It makes you experience time as a very constructed effect. And it's what can we say about it? So the question is, isn't Moore's law more a limitation on growth? Well, yes, it is a limit of this kind of sequence of automations that we can perform. It doesn't mean that we necessarily reach it, but so yeah, there's you can make like a political argument that we don't actually, it's not so determined that it's going to be reached, but like let's see what happens. Let's see why we can expect that this kind of desire of automation arises. So if you play this game, it's I think a lot of people experience it as a game which is really you really continue playing it, even though your particular emotions about it may be like conflicted, but you still continue playing it. Because why? Because the moment you are bored of clicking one particular button, it gives you a new kind of mini game, right? So and then you kind of have to figure it out, and by the time you get bored of it, there's already like a new mini game from it, right? And at the same time, when you play it and you feel, I'm probably not using my time in the best way by making paper clips, by clicking a button, it tells you, of course not. You can make your time much more productive. You can make auto clippers. Let's just go faster. Why not? Your time will be used in a much better way. So we have this kind of movement where the abstract labor, it's actually always already almost devalued. Where, if labor is abstract enough, it's bound to be automated, and since it's going to be automated soon, it's very hard to value it. There is like a lot of Marxist moral arguments against abstract labor. I think this is kind of one of them. But here we see that, just like perception of value, not just perception of value, but also actual market value of abstract labor just bound to go down. And I was thinking about the other day, and there is this sometimes some kind of American president wants to teach everyone programming or something, and then you realize that for a lot of people who end up being doing automatable labor, it's actually going to bring more depression, because when you do some kind of labor and you don't know what it takes to automate it, if you think that programmers do something incredibly complicated and weird and not related to your labor, it's much easier on your soul than feeling that whatever you do, a machine could do in a minute. So in the same way, abstract labor is never fast enough. It's not fast enough for capitalists who wants to have everything cheaper, but it's also never fast enough for the laborer, right? Which is, as Marx says in Machines Fragment, is exactly how capitalists sell you with automation, how they make you excited about being replaced by machine, because you feel that you want to do everything faster. So in this way, there is this kind of desire for automation, which is inherent in the idea of abstract labor. Abstract labor is a labor that just asks to be automated. It's very hard. It's very hard not to automate, I would say. It's always all of this. Why I want to say that Moore's law is not just limitation, but is actually a state of things, in a way that it's much harder to avoid automation of abstract labor than to automate it. So, however, automation of labor is itself a kind of labor. What can we say about it? If we look, if we go back to the game again, and we see how this whole process is going on, we will see that so before you automate a particular step, you have to actually engage with the step. Before you can move on to the next mini game, you have to play the previous mini game. Before you automate the labor a little bit, you have to perform it a little bit just to see how it works. And so there is this kind of irreducible foundation in the existing abstract labor. It's not strictly necessary that whatever automation is there already was performed by humans, but it's, I mean, at least the programmer who's doing it is going to kind of do it step by step at some point. What else can we say about this kind of labor of automation? Now I see that I thought there is a lot of material, but I could actually speak much more slower. So one of the books in the syllabus is called Mythic Man Hour, and it's an important book for history of engineering, of software engineering, because it's one of the first books where people who would organize software engineering labor would look at it as a labor and would look at what kind of effects time and social situation and interaction of every particular stakeholder produces on how system works, how it is built, how it behaves. And so one of the chapters in this book, it's also called Mythic Man Hour, it compares labor of building a software engineering system with gestation, with being pregnant, you know. And it says you cannot, if you need to speed up production of a baby, you just like bringing more women is not enough. It's just no way, you know, it has to grow. And we can interpret it as that, you know, this kind of automation is a process of nurturing and negotiation of self-sufficiency. This machine that will replace the current workers. It you know, there is a process of negotiation of self-sufficiency in the sense that, you know, you just ask machine, you know, please produce me some paper clips, and it says, you know, look, I need this, and you know, and this is a process of software engineering, if you know, in a very metaphorical way. And so there is this kind of this is a kind of idealistic metaphor of this process that shows that there is something unobstructable here, because it's not abstract in a very particular way, not because it's very it's not because, you know, every programmer is some kind of author who's irreplaceable, but for a different reason, just because, you know, the usual laws of abstract labor do not readily apply to it. You cannot expect to like just speed up things by adding more people. Another metaphor is my metaphor. It's like a police metaphor, which is about automation as negation of abstract labor. So, you know, if the goal is to get rid completely of abstract labor, you know, it's actually kind of similar to how, you know, Max Weber or Carl Schmitt define state as, you know, monopoly on violence, or this kind of process of expulsion of violence. Basically, why does the government need police? Police is a particular kind of people who can use authorized to use violence to get rid of other violence. So you have this kind of violence that is portrayed as necessary by the government, that ends up being actually a source of violence. And since you know, if we kind of define abstract violence in the same way as Marx defines abstract labor, if we say how Marx defines abstract labor, he says that there is a use value of labor when a person makes something that he can use, and there is an exchange value of labor where a person makes something which can be sold at exchange as part of the commodity on the market. And abstract labor is labor that removes all kind of use value. It kind of just tells the laborer, you know, if you make this will make this amount of money. But there is no understanding here. It's not necessary to understand here if the labor is sufficiently abstract. Why do people need these things, or like what kind of a use value of it? How this use value is related to exchange value? It is a abstract labor is a labor that makes things that are completely removed from their causes to exist in the social situation. The same way, abstract violence is a violence that ignores its causes. You know, if you know there is a murder or theft or burglary, a policeman is not concerned with kind of structural reasons for any of those crimes. It just gives crimes exchange value. It just says, okay, this crime is 2 years, this crime is 10 years, but it doesn't concern itself with structural causes. And but it doesn't mean that the structural causes do not continue to exist and to act upon a society. And so the violence that is made necessary by a particular social situation, some kind of regimes of exclusion, of racism, of some kind of class discrimination, they make, all those regimes make some violence necessary to perpetuate themselves. And it is actually quite often that, police becomes this perpetuator of this violence. They try to remove violence, but what they actually removed is the link between violence and its cause, and as such, they do the violence themselves. And I think it's an interesting metaphor here, because also like software engineers have to, or other kind of engineers have to, when they negate all kinds of automation, they end up performing, investigating, having to understand a lot of things that made the labor have this particular form and have this particular use. So they end up discovering particular kinds of unautomatable, unabstractable labor and performing it. So I would say, I think we can say that labor automation is not itself an abstract labor. But again, not because it's very personal, not because it's some kind of, it's not abstract labor, not in the sense that Marx would love, probably, some kind of, it's not because it's good in a way, but it's just a little bit of a different thing. It's just, it defines itself against abstract labor, and in this way, it's not. And we can also do like a Hegelian move here, and they say that automation of automation reveals this labor of automation as resistance of material, right? And so when software engineer tries to automate and then automate further and then automate further, he constantly stumbles upon situations that don't easily lend themselves to be automated. And that is how Hegel defines matter, right? As resistance in one of the ways. And so we can say that in this way, programming labor continuously encounters, a kind of materialist part in a way of labor in its way. Okay. Yes. Okay. Daryl mentions Amazon CloudFormation. Oh, yes. So Amazon is going to be our topic for next time, because it's just such a pure example of a thing, but it's also a little bit of a different thing. So it's as I promised, we will look a lot of at real examples rather than abstract thinking as today. I just wanted to kind of map the conceptual field, but definitely Amazon is a very good example here, because it just it has no other goal if you look at it. Any thought of Atwood's law? Atwood's law, thank you for mentioning it. I didn't think of it, but it's also going to be a very good topic for next time. So thank you, Cameron. Because next time we're going to talk about platforms, and we'll see this. I'm not sure if incentivizing a more deliberate and nurturing automation. I'm not sure. Let's keep it for Q&A, and maybe you could talk about this a little bit later.
Yeah, we will have last half an hour for Q&As and other things.
I think we will have actually more, because
even more. Okay, cool.
Yeah, it went fast. Okay. So let's see what kind of impediments there to, is automation of automation. And when I'm saying impediments, I don't mean that there is it's arguments against possibility of automation because one way to look at it is to say that automation of automation already exists. I'm saying just like this kind of hurdles that I encountered here. So what I want to say here is basically that you cannot completely automate programming because the moment you automate it a little bit, with automation, you already produced a new kind of programming that uses it. So by automating programming, you actually just doing programming. All you get is more programming. And if you kind of imagine, this kind of a machine that writes code that is trained on, I don't know, neural network to write code for you, actually, it will be this absolutely the same thing as just inventing new abstract terms and adding them to programming code. It's just a particularly uncomfortable way to do this, but all you did is introduced a new abstraction. So to give you a metaphor, I would say, if you can fully explain a long book in a sentence, the sentence is probably enough. Imagine a machine that you give it like a sentence and it writes you a whole book on this subject, like what's the point of it? If I'm not saying, if the machine also Googles things for you and reads other book, like just some kind of production of like automated speech, it has same amount of meaning as a sentence, it's you just like you found some abstract way to define the problems, maybe it's enough. And as I say, we can imagine a social situation where such a book would actually, such a book writer, automated would actually be useful, because it's incentivized for people to write really long books in some cases. But if it's not, there is really no point in automating writing completely, right? Maybe automating some parts of it, yes, but completely automating it, because it like the definition of a task will be the actual important part of it. And I was thinking about how to it's an aesthetic argument. Let's make it more specific, right? And I was thinking about Twitter bots. And Twitter bots are, I think, the most successful example of artificial poetry, right? So there is a lot of people who create things for artificial poetry, but I haven't really met any kind of genre of it that would be actually read, except for Twitter bots were really, really popular and really read and really interacted with for many years. I'm not sure about right now, but I think like for a few years, it was actually fun and engaging to look at them. There was even, I think there was a bot about xenopoetry, like which would parody some kind of a poetic discourse of accelerationists. And other bots. I think it's a full of kind of artificial writing. This as art form, that was definitely the most successful. But let's see what happens here. Let's see what happens with meaning, like when you create such a bot. Like, let's try to explain what's the value of it. So imagine I read enough, some kind of, I don't know, write accelerationist discourse, or I read enough, I know, Lacan or somebody like this, and I write a bot that based on cliches, based on jargon, based on the usual kind of ways to define problems. Paradise makes a parody of this discourse, and every like 4 hours makes a new tweet, which feels and looks like as if like one of the participants of the original discourse actually wrote it. And it can actually be amusing and hilarious, but what kind of poetic meaning of it? So as we see, in our conversation about the monologue about automation of labor, when you automate something, it means that this something becomes defined as abstract labor, right? To automate something, you have to it has to be abstract labor. So if you partially automate something, it means that you automated, the automatable parts, and then you have the leftover parts, which are actually not abstract, which are actually, I don't know, different in some sense, I say, not abstract. It's not, and what such a Twitter bot does, it extracts this kind of abstract labor core of the discourse that is, you can say it's meaningless, but it's very important for discourse, right? To have this kind of core, so that when people share, I mean, I don't have to probably defend it to you, but you just you have to have this kind of core of discourse to make sure everyone is on the same page. But then you have this kind of standard. You have this kind of, everyone has this kind of standard of abstract labor, of being, expressionist philosopher, so that you can compare any work not against some kind of absence of writing, but against this abstract and meaningless writing, to see what kind of things are actually being said, right? Because every, if you have some kind of article, and you read enough articles in the field, you will be able to recognize what is actually at stake here. It's not always very clear. It's not very easy to discern. And what with such a Twitter bot does, it kind of makes a material expression of this abstract sort of discourse against which you can compare everything else. You can just you compare your writing with the bot's writing, and what you're trying to say. So it's kind of, I would say, this kind of idealist arguments, impediments to automation of automation. But there is, you can also look at it in a kind of materialist way, and because, as I said before, every time you automate a particular labor, you encounter the material conditions of this labor. You have to interact with the material. And when you interact with material, you have like problems, like this kind of resistance arises. That you can make a lot of examples here, like limits of resources, or there are more various, there is like different kinds of wires. Then there is a variety of desired outputs. You want to make very different paperclips. There's like problems with people who work on it, all kinds of things that can happen. And it is exactly those problems that bind, this current speed of any process to the particular kind of labor that has been the limiting factor. It's if you remember all of my plots, right? There is always some kind of linear plot there, which is the labor that is actually important in that particular kind of part of production. And this labor is limiting because everything else is automated and just goes quicker and quicker because of it. And it's only so slow because of those problems. It's only so slow because it's not automated yet, because it's not abstract enough yet. And since it's not abstract enough, it means that it has a relationship to materials. Okay, what happened in the chat? Would idealist impediment be overcome if problem of PNP would be solved? No, I don't think so. I mean, but let's talk about it a little bit later and see what kind of meaning it can have here. Okay, boring philosophical moment. Okay, it's boring because maybe let's keep it for Q&A, and we'll touch it if we have actual questions about it. Okay, so Any more questions about what I just said about time and automation? You know, if we look, I don't have a particular theory, and I don't think I should have a particular theory about how time is produced here. But if we look at all the things, you see that we might say that it is this linear relationship that produces time in this production process. If you look at Machine's fragment by from Marx's notebooks, you will see that maybe actually it would be best to label axis of this graph as circulating capital versus fixed capital, because it is not just it's not just time that is needed here, but this process of a little bit of labor was performed, products were sold, workers were paid, labor was performed again. It is this cycle that that defines the ability to make sure the whole system is automated. And I think we can tie this experience of time because to this kind of labor, because when you're not doing this labor, when you're just sitting there and waiting for things to happen, or when you automate it, time feels a little bit differently. You feel that there is no time. Time is, you constantly feel that it's not fast enough. And at the same time, it's this feeling of lack of time, I try to, I really want to use it to understand one particular phenomena known that, there is a different game of automation called Factorio, which is same topic, same cybernetic loop, just a little bit more complex and more interesting to some people. And if you look at how many hours people put into this game, is just insane. It's just thousands and thousands of hours. Like you can, Steam gives you the stats, and people on Reddit dedicated to this game, they show screenshots that they wasted like thousands of hours of their life on this game. So it kind of sucks you in. You cannot disentangle yourself from this loop. So I think there is a relationship between time and labor here, and we can say labor, abstract labor produces particular kind of time, and labor of automation produces a different kind of time. And being a manager and being a capitalist here produces feeling of no time and produces abolishment of time that can, I think, kind of explain why after a person succeeded a little bit in being a capitalist, he just cannot stop. He just goes on and on. Okay, so any questions about this? Was there something in the chat?
Cameron had a question in the chat. I don't know if you already addressed this about exponential.
In acceleration of circulation. Well, exponentiation is a particular kind of function, the speed of which is the same function, right? So if you try to move to a level when you accelerate exponent, it's still going to be exponent, right? So that's now how it's related to circulation. It's a bit more complex argument, and I think it's very Marx specific. I think I'm not sure if I would be even willing to properly explain it, but so Marx differentiates between fixed capital, which is all of the machines, building, all this kind of stuff, and circulating capital as this kind of total sum of everything that is being circulated right now. So if you're making paper clips, selling it to pay wages and wire, all of this is going to be a circulating capital because it doesn't have any particular any one particular form, which can be very easily and uniformly quantified. Now, with circulation, is a kind of a loop, And it is this circulation that allows fixed capital to grow. Since your fixed capital is already the limit of your capacity, you can spend fixed capital to purchase fixed capital, right? So you have to circulate it once to get surplus value, to get profits, and invest it in your fixed capitals. And this one episode of circulation is can be just one tick of this kind of clock, perhaps, right? I mean, I think there is a possibility to create an interesting theory of time here. Probably even somebody created it, but I don't think it should be me today. Other questions? No? Okay. Okay. So, as I said, what is, for me, a very interesting part is how this kind of engineering language grows. And automation creates new languages, as I explained, with terms that are being abstractions over terms of the original language. And in programming, you can see it quite clearly, but I think it's not limited to programming. But in programming, you can see it quite clearly. And that's why I proposed you read an essay by Brett Victor. It's called Up and Down the Ladder of Abstraction. Now, this essay is one of kind of ethnographic material for us. You know, it's I want us to differentiate here between kind of discourse produced by philosophers, by theorists, and discourse produced by engineers, for engineers. And I want to differentiate it because it has, as I said in the beginning, it has different place in the labor structure, and thus it has a little bit different, it ascribes a little bit different meaning to everything. And that's why when you read Brett Victor's essay, or when you read The Mythic Man Hour, I want you to engage with it not just as a piece of literature, theoretical one, right? But I want you to interpret it as an indigenous text, how do you say it, authentic text, right, of the field. So Brett Victor is somewhere between software engineer and UX visionary. As a, I don't know, he has a good CV, and he's kind of one of his dreams is to provide this kind of labor of programmers, abstracting things, to provide it with some kind of visual counterpoint because programming, you know, when you invent new idioms, it's a very non-visual thing. You know, unlike architects, for example, when I was looking for examples of software architecture, all of them, most of them, they look really ugly. You know, it's really not a visual field, and it shows. And I think the reason for it is that you have to invent and provide abstract terms, you know, before you can give them some kind of visual justification. Still, it's important for Brett Victor that there would be some kind of visual help for programmers when they deal with all this kind of complicated levels of abstraction. So he writes this essay, which I think it's quite influential. I think more or less every engineer stumbles upon it in their career. And what is it about? Yeah, I don't think you actually, I don't think I should assume that you went through it. So let me open my browser. Okay. Okay, so what Brett Victor sets out to do is to explore an algorithm of, you know, self-driving car, but it's not a fancy self-driving car. It's a very simple algorithm. Still, he looks for ways to explore it, right? To understand what is going on. So that is in this little animation, you can see how the car is supposed to behave. It constantly turns by a fixed degree to try and follow the road. Now he says, if we want to explore such an algorithm, just looking at plain animation over and over and over again is not very helpful for us, as much as being able to manipulate this timeline, like in a video player. So you can actually pick any kind of step and see where the car is there. Then he says, okay, let's consider the effect of this angle of turn. How is it? Rate of turn. Let's consider what would happen if we change it. So he says you can pick here any angle, and you can see what happens here, right? Still, he says, it's still not clear what happens. Let's replace just plain this as an animation. Let's replace it by a thing called trajectory. And here you can change this angle of turn, and you get a different trajectory of the movement of the car. So what happens here? It's exactly what I was saying about introducing a new abstract term. So here, there was a cognitive labor of following the car's movement. You have to actually use your eyes and be really attentive and watch where the car goes. However, here he introduces a term called trajectory, which was nowhere near in previously, that abstracts away one of the particular parts of process, namely path of the car, to automate this cognitive labor of following the car's movement, right? It just got so much easier for you. Then he does more operations. Like here he says stepping back down, because he says, there is always this kind of twofold movement, right? So on the one hand, sometimes you abstract and you introduce a new term, but then sometimes you have to go back to see how this term actually, what is this term in relation to what it's abstracted over. So here he has the same trajectory, but he puts car back into it, because when you have trajectory, sometimes you just want to see what's going on. You want to see how the car looks like on this trajectory in a particular step, because if I look at trajectory and I see a car on one of the bends, it might not be clear for me why does it turn like that, right? However, if I put the car here I can see that the reason why it went off the road, because I see that it actually tries to turn, right? So that's kind of the counterpart to abstraction is this how can I call it? I kind of encounter the material part of it again, specification. Okay, I'm not going to go through the whole essay. I think it's interesting, it's cute, interactive. Definitely try it if you didn't. But let's see what we saw here, right? So as I said, yeah. So we have two tasks of a programmer, right? So on the one hand, you have to invent and introduce new abstract terms to automate a particular kind of labor. You have very particular kind of labor, and every time you introduce a new abstract term, you automate particular kind of labor. A lot of time, programmers automate their own labor. It's just the reason why programming has a lot of abstraction is because programming is very readily automatable. You can make more and more abstract structures in programming languages, which just automate previous labor of programming. And at the same time, it has this step back down where he has to make sure existing terms actually represent their denotations, or has to always go back to the relationship between abstraction and whatever it abstracts over. And in our jargon, it's called the fixing bugs. And what it does, it widens the applicable scope of automated labor. Right, so I automate making of paper clips out of particular kinds of wire. Now I have to go back and make sure it's other kinds of wire also fit. So I have to try them out. That's kind of the other part. You can say, materials part of that. Okay. Yes. Okay. Okay. So fortunately, that's all I have. What we're going to talk about next time. So all of these things we just talked about, automation, it has been the main topic of capitalism for quite a long time, but it doesn't seem so anymore. It's not anymore the most important and interesting part of contemporary capitalism. Kind of a new stage, which is very much defined, or at least has computer technology as its avant-garde. So it's not to say that whatever we learn today is useless, just not the way you probably will make money, I guess, if you care about it. But it helped us map the conceptual field, because next time, when we're going to talk about platforms, we will have to understand them in relation to what we talked about. We will have to understand what exactly changes in like all of this labor structure and way commodities exist and all this kind of stuff in relationship to this kind of industrial capitalism built on abstraction and automation of labor. And I just gonna say now, because I want, since we use a lot of what I say, authentic material, I want to talk a little bit about what it is, not just let you discover it in syllabus. Strategy is a blog which is a very huge authority on contemporary economics of computer technology. It's this guy was writing this blog for I think a decade or so, and he's considered a very renowned expert. And it's important that it is a blog because if you write a book on Amazon and you publish it in 2 years, it's already not there. With blogs as a very important theoretical medium here, just because the field just moves fast enough. And I want you indeed to read about Amazon, and I put 2 links in syllabus that I think are most important or interesting. But you can definitely click around. I mean, if you're interested, I hope you will be, or maybe on other companies as well. And he explains strategy of Amazon. He explains structure of Amazon, and it is his understanding of platform, which I think is the most useful and powerful. And even though I wouldn't say that he at any point makes any kind of theoretical effort to define it. Still, however, Strategy is a blog about economics and business. And that's how a lot of people talk about platforms, like Nick Srnicek, for example. I want to talk about it in a very different terms. I'm going to talk about it from kind of technological perspective. But this economic context is very, very important because we are materialists. And I also propose you to read Conway's paper, How Do Committees Invent? In this paper, he introduces a thing called Conway's law, which is a very interesting twist on what we've been talking here. And it basically says that if you have any kind of organization and it builds a system, the system will be structured exactly as the organization is structured, right? So if you have a company which has two offices, the system will have two components. If you have a company where people talk to each other a lot, it will be a system which has a lot of like internal communication, right? And I think it's interesting because it shows very precisely this kind of process of automation of labor, of relationship between labor and system on this kind of structural in this kind of structural situation. So I know, interesting paper, and I think it's I don't know, can be applicable. I'm not even sure. I think it tries to have a wider scope than programming. So maybe you will find it useful otherwise. Yeah, and with everything that we're talking about, you know, as I said, most of important writing and technology was not really mentioned labor a lot. So I think this is a kind of the task we have to take upon ourselves. So try to interpret it in a very materialistic way, or in your way, and read it kind of critically and philosophically. Okay, that's all I got. So let's take 5 and I smoke a cigarette and then we do a QA. Okay.
Okay, let's do a 5 minutes break and then we can reconvene at 9:35, let's say. You can just mute yourself, and I mean, you're already muted, but you can just turn off your cameras if you feel like, and then come back. Maybe we can slowly restart when everyone is ready.
Okay, now I know that I need 5 minutes to smoke half of a cigarette.
Next time we do more. Should we open up the floor to any kind of questions, clarifications, comments, whatever you have on your mind?
So I think it's, since we have enough time, maybe we could go through a round of introductions. So I'm interested in, I mean, you can tell a little bit about yourself. Also, what do you want from this seminar? What is your kind of ambition? And also, yeah, just any kind of, if you have any questions or feedback, you can say about this, and after the round, I will try to address some. Okay.
So I could just call people, and then we can, in order that I see you on my screen. So first up for me is Cameron.
Hey. I'm Cameron. I just graduated with a degree in computer science from the University of North Carolina, Greensboro. And I'm looking to basically most jobs locally are just nowhere to be found, and just looking to learn.
Thank you. Next one is Georgia.
Hi, my background is in architecture. I graduated some years ago, but right now I'm trying to make a shift in a more artistic practice. I have used digital media and some scripting, some ready-made frameworks with machine learning stuff. And I'm mostly interested in bridging some of the notions you, Valentin, mentioned for us in this course, like bridging the abstract back to the specific, which for me is narrative and storytelling, and how digital media can, what role can they play in this process? So a bit like reverse engineering them or hacking them somehow to find out if they can deliver the traditional message of pure storytelling.
Thank you, Georgia. Next one would be Nikki.
Hey, my name is Nikki, and I studied interaction design, just kind of like a broad umbrella term. And I did a lot of traditional design as well. And I come from more of a design thinking or engineering thinking practitioner way about things other than a philosopher. But I'm interested in this discussion of labor versus programming. I'm not sure what I want, like what kind of critique I want to pursue at this moment. I think I'm like critical enough as it is. I'm always trying to pull back on the critical right at this moment, but I am working on a media installation that involves different automated components, and I think maybe that's what I'll work
on. Thank you, Nikki. Raphael, would you go next?
Hi, everyone. It's a pleasure to be here with you all. I'm a social scientist from Brazil. I'm studying computer science also. I have some background with anthropology and philosophy, and I had a sudden shift into computer science, and I'm immersed in this. I think in this experience as a ethnographic experience, and I'm trying to think a little bit about it. And I usually, sometimes I code some things with blockchain, with ontologies, like trying to apprehend some semantic meanings of these informational landscapes and how they are vicious sometimes, how we treat things like resources, like we treat the nature as resources, and we reproduce these habits, these thinking habits, in also in computing, in programming. And I had some thoughts about the lecture. Um, this question of time, I don't know. Sometimes we discover things and we have to rearrange, like these exponential models. I was thinking like where entropy would, how it would rearrange it, and how, depending on the information that we have, we would manipulate things by other means, by other ways, maybe. And just a thought that I had with concerning this, some of the some of these terms, some of these frameworks that are used. Maybe our imagination is determined by this engineering way of thinking. And just another thought, if it's okay to share, I had this image of the engineer and the bricolo from Levi-Strauss, thinking about a little bit that we have these ways of rearranging and interacting. This is, it's a sort of politics, I believe, that's that's also influences science, the way science works. I don't know. Just some thoughts, but that's it. Thank you.
Thank you, Rafa. Valentin, will you gather the questions and then we can finish the round and then answering
Yes,
answering
I'm writing down everything.
Okay, cool. Thanks, Rafael. Next one, I have Frederick.
Hi, how are you? Well, my field is literature, and I don't have a lot of experience with computation or computing science, but I'm definitely interested on the interrelation of these sort of strata of theory. I really like what you said about xenopoetics and the automation of discourse. I think we can make a lot of dichotomies between language and its automation, or whatever you want to call it, and I'm interested in that.
Thank you, Frederick.
Thank you.
Nikita, could you introduce yourself briefly?
Yeah. Hell. So my name is Nikita, based in Moscow, Garage Museum of Contemporary Art, where I'm doing actually like 2 jobs, and one of those is like a managing web development for the museum. So that gives me kind of a daily hands-on experience of communicating with programmers and designers and so on. And another thing I'm doing is I'm a research curator for the program Garage Digital, which is a program on supporting artists and researchers who deal with technologies in different ways. And actually, I have to mention that Valentin takes part in this program, which I'm quite happy of. So I'm just generally following what you're doing, and I'm quite interested in both of the fields to implement what we're going to research here.
Thanks, Nikita. Next one, I have Jose.
Hi, I'm Jose Antonio. I'm speaking from the south of Brazil. I'm a legal theorist. I'm finishing my PhD thesis at the moment, and among other things, I'm trying to think about transformations in legal theory related to contemporary transformations in technology. So I'm thinking a bit about algorithmic governance and platform sovereignty, and all of these ways in which legal theory seems to have to enter into a kind of integration with media and technological um, concepts and practice as well. So at the same time, I'm not really I don't have a lot of technical knowledge in that. I've started to think about this mainly through a theoretical path, and I've started getting my contact with this through theorists who somehow are already kind of translating these questions into a theoretical, philosophical, social discussion and trying to bring that into legal discussion. But I feel like it would be really good to actually, kind of using this as a path to actually get into the more direct digital engineering and programming and all of that, so I can actually get a grasp of this. And I think this seminar is really good for that. I already felt with those like initial interactive things, like it's really something that I already have from other places. Like I've programmed like little games and stuff like in the past. So I think this kind of, even if you don't understand it in a very like detailed level, to get an intuitive interaction with this stuff it always helps you like find new paths in thinking about the social and political and all those more abstract consequences of those particular modes of operation.
Thank you, Jose. That's great. Jesse, can you go next?
Yeah. Hi. I'm Jesse. I'm doing a PhD.
Oh, sorry for mispronouncing your name.
That's all right. Always happens all the time. So there we go. Okay. So I'm Jesse Benjamin. I'm doing a PhD in philosophy of technology at the University of Twente, and very much like Jose before, I take the literacy part quite seriously of this course, I guess, because I want to get more of a handle on the vocabulary that I use in my writing and obviously in my research as well. And I think for me as well, the start of this seminar was very interesting, because what I think about in my research is how these layers of abstraction and abstraction and their interrelationship and their relationality link back to what we consider our everyday phenomenal experience. So that is kind of my area. How do these layers of abstraction in like human technology assemblages bring forth specific modes of relating to the world, and how is what kind of technological stage we're in now, is it qualitatively distinct in how its structures are related to the world and each other and objects and everything, and what can we, how can we conceive it, and how can we possibly think about, building a methodology around anticipating or structuring, designing things accordingly. And that's basically what I do. So very much looking forward to how this continues.
Thank you, Jesse. I have Daryl next.
Yes, I'm a manager at a university, distance university, and responsible mainly for the learning management system. And my interest has been in open source primarily. Open source, I guess, as a political statement in response to how to break out of some of the loops and cycles of circulation that capitalism incorporates.
Thank you. And then the last one is Shilpi.
Hi, I'm Shilpi. I won't be sharing my video as I fear that the internet may get disconnected. I hope that is okay.
Yeah, no worries.
I'm a communication designer, illustrator, and an animation artist. I'm also taking the certificate course with the New Center. And I found the description of the course, the seminar interesting, and that is why I'm taking it.
Thank you. So I think that's everyone. Valentin, do you want to address the questions, etc.?
First of all, I'm really happy and honored that so many people from different backgrounds are here, and I hope we will find a way to enrich discussions, you know, from all of these different perspectives that we have. We have artists, we have people who are interested in legal perspective, we have people interested in particular kinds of technologies, we have people with very, proponents of very important, romantic criticism of technology, like Heideggerian. We have, and I think it's this is a kind of a multi perspectual view that I really hope to create in this seminar, and let's see how it plays out. And just first of all, to answer to kind of most of questions here, I think it's very important to understand the distance between engineering kind of mode of thinking, or we can say language, but maybe not even language, and philosophical and some other ones, right? It's engineering mode of thinking is different in a very particular way, and it's the reason why I promised you to interact with real technologists, but instead I gave you some kind of weak Marxist lecture, is because I want to be also very materialist in how I define it, to find some kind of specific causes why and how it is different in a structural way. And this difference is very important to me personally, because I'm kind of, I used to feel very, very split between it, right? Because like on my day job and my evening job, when I would study all of this philosophy, which is inevitably romantic philosophy, and romantic philosophy is really not a good approach for programming, because I mean, by romantic philosophy, I mean, for example, Heidegger's notion of Gestell, right? Or like all kinds of trying to ascribe like to a subject some kind of poetical, exceptional poetical possibilities. So I'm not against it. It's very important to me as well. I was really working in kind of my mind to reconcile it with my engineering mode of thinking, which is very, very different, and it has very different kind of I don't know. I'm not even sure if I can say metaphysics. Very different understanding what is real and what is not, what is interesting and what is not. But however, I don't think it's just my kind of personal problem, because there is this tension between kind of scientific, legible, understandable world that can be looked from both of those sides. And I think kind of poetics or aesthetics you can create by going through this engineering thinking, not by dismissing it as boring, by kind of going through it. It can be actually also interesting and productive in our world, where technocratic mode of thinking is so prevalent. It would be really impossible to get rid of it. So it's this kind of tension between those two languages is for me the main interest, and that's why the way I try to study technology, especially in the seminar, is actually a very romantic philological approach of, always like very different, trying to find different theories to explain things, trying to talk about affects, stuff like that. Another thing that very interests me very much, and I think from hearing you would also be close to some of it, is I'm definitely interested in what kind of really weird affects those grand cybernetic systems create. By cybernetic system, I mean, there is like programming when you sit at home and program, but when then there is a huge economic machine of, innovation, automation, labor that you're part of, right? And we are at this moment of time where we have very immediate access to this machine. We have internet, we have all these things, and it produces particular kinds of, affects. It produces a particular feeling of time, maybe something else. I'm not even sure if there is even a way to name or recognize the things, but definitely there is something to it. So that's another side of story, which I think kind of my path to get to it is by exploring those macroeconomic situations and structures. Now, there is a certain, I would say, notion of engineering honesty that is very different from, say, philosophic honesty or some other kind of honesty. When you're honest engineer, Google has this process called 5 whys, which is every time there is a problem in Google, something happens. Just, I don't know, some data was lost, there was a security problem, there was an outage, some service was unavailable. They go to a process called 5 whys, where they kind of ask, why it happened, and there is an answer, I don't know, I forgot to press the button. And then there is a second why, why did you forget to press the button? And then you can kind of, abstract from the first problem, and somewhere between the third and fourth problem is something very actionable. There is always some kind of process, internal process in Google, that can be improved and changed to overcome this problem, with initial kinds of problem. And it's why I connected to honesty. It's because it's a system to avoid assignment of blame. In a very big corporation of engineers, blame does not get, in a good case, does not get usually assigned for problems, especially like technological problems, or even problems of sloppiness, because everyone is human, everyone makes mistakes. So, and a big corporation like Google, it usually tries to find ways to avoid blaming people and to find some kind of slightly higher level of structural causes for things, and I'm saying slightly higher level because of course they don't go into kind of structural Marxism to explain these problems. They go into something smaller. And I think it's an example of engineering honesty, because engineering honesty's goal is not to be a better person. It's not to be sincere. It's not to create a society of people who trust each other, but to create a more reliable system. And it has very different ways to test it, with this kind of mode of confession, Foucault's pareisia, right? All these things, they need to be reinvented, for engineers. They're going to just look differently for engineering laws. And I think this kind of honesty, it's very interesting. I'm not saying it's better. I think it has very serious limitations in many cases, right? But it just has a slightly different approach to morality and approach to metaphysics as well, because when you're doing any kind of
could someone mute themselves? Jose, you might not be muted, and someone else. Thank you.
Yeah, I think, I'm not maybe with Toyota, yes, and is 5 whys, or you mean 6 sigmas maybe, or maybe it's part of the same process. But I mean, yeah, I mean, engineering has long had this kind of different kind of process for all those things. And I think it's interesting to see how they would play out with, you know, with other kinds. You know, when I read like Intelligence and Spirit, for example, you know, you can actually see that it's in some ways you can say that there is a different kind of honesty there. You know, not that, like engineering kind of engineering kind of approach to things is clearly an inspiration for Reza, right? And I think it's interesting. Like, I don't trust that it's a mode of thinking that is better, but I think it's very contemporary, and it has a lot to teach us. And understanding it, even if you're critical of it, is going to be very beneficial, because right now the world is written by engineers, for better or worse, and they give us language in which we talk about a world, and it's going to be legal language. It's going to be even a language of new artistic media. It's new languages of ontology, right? As in Bitcoin was mentioned. All these languages are just languages that created in a slightly different mode from, you know, languages of, say, social change of a romantic period. So I want to kind of find ways to interact with this mode and to see if I can like explain it to you, and we can see not just how it works, also reasons for it, maybe some limitations of it, right? So that was my kind of general response to most of the mentions of your particular interests that I heard. Okay, yeah. So it's you know, this difference in languages, it has especially detrimental effect because our language of, you know, philosophy or everyday life, it has the same word. For example, when we say, you know, open source, right? It's kind of from outside world, it's a very utopian model of collaboration, but from kind of economic engineering perspective, it has a very specific economic meaning. It's part of capital. It's again, of course, this being mostly part of capital enables, you know, this lines of flight or things that untimely things to happen in the field of open source, which are much more interesting and beautiful than just being part of capitalism. But to see them, you have to learn how to subtract this kind of global and totalizing meaning in a grand scheme of things. I think the best way to kind of preserve romantic thinking, which for me is very important, I want to believe, you know, is not by kind of repeating again and again that we have to think about everything in those terms, in the terms of freedom and self-determination, but I think it's best done by subtracting the determinist part. You know, you just go somewhere and you say, you know, my romanticism is so strong that I will survive a dose of determinism, because I know that it only will help me to see things that kind of don't exactly fit. Exactly, you know, like in programming, you know, you do an abstraction and then you see all of the exceptions. So with this, what I'm also very interested in is exceptions. And you know, when we're going to talk about things, we're going to talk about like these weird little weeds that grow out of cracks in the asphalt that of everywhere, like, because there is some of these technologies like create a whole aesthetic fields, right? Because we're going to talk about computer generated images, right, for example, and it has its own meaning. And it also, you know, if you read some like very good practitioners of those fields, you understand that they actually apply a very materialist critique of particular forms. even though like they not necessarily try to be Marxist just because they're good artists, right? So so that's kind of my stance on the relationship between engineering and the world. I think we have to understand it to be able to subtract it, at least from our daily life.
Are there any other questions or comments? Also, anything not specifically related to this, might be also a bit more logistical, whatever, really.
Interested in like I noticed that the notion of romanticism appeared a bunch of times in your last sequence of commentaries, Valentin, and I was thinking about that a lot recently, even like related to that question that I made on the internet about Carl Schmitt. I was like describe his position in relation to the discussion that I'm doing about the relation of law and technology as a romantic position. But I hadn't read yet his book about political romanticism that just is called Political Romanticism. And I was like, okay, he's probably going to be like somewhat in favor of that because it sounds pretty romantic. And then he's like, the whole book is just bashing political romanticism. And that's like the...
It was his exorcism.
At the
He
same
tried
time,
to stop being romantic.
Yeah, I think he was like in conflict maybe because I've seen commentators saying that even though he's against romanticism, he's pretty romantic. Interested in exactly what you mean by romanticism as this specific type of philosophical approach, and what you think about Schmitt also in that context, if you want to comment on that.
So obviously, I mean it in a very kind of general way, because I'm not trying to define what we're going to do here through it. So I feel free to just kind of put a lot of different ideas there. But I think one major feature of romanticism that is going to be influence of this course is that romanticism implies that there are entities of the world that just exist independently of this, huge, I would call them cybernetic cycles. They can be economic cycles, but there is also like cycles of tradition, like language change, all of those things. They create some kind of big cybernetic loops, which are, foundation of my own personal ontology. And being a romantic is expecting that things exist outside of us, that things exist outside of like economy, outside of language, outside of those things. It's just kind of independent way. Now, I kind of, on a level of my personal sympathies, I want it to be true, and I'm not trying to. I don't want to build a kind of a picture of the world completely determined. But I think the most strong way to do it is to attack head on and to recognize all the different ways in which our world is deterministic, and then this kind of the very process of escaping all this determination is going to be the process of acquiring independence, which is probably a familiar philosophy to a lot of you. Now, as to Carl Schmitt, I mean, it's finally he actually he mentioned a lot by philosophers of technology, like Bratton, for example. It's and I'm not sure even why. But it is because I was also interested in Schmitt. Maybe there's something like about Schmitt, even though he never talked about technology. Clearly, this notion of an order that is arbitrarily defined by one specific act, and on which everything else kind of grows, is something very close to engineering. My understanding of how things work. I think we can say that Schmitt defined country, national state as a platform in a way, because what with like Hobbesian way of defining state is that, you know, to be able to communicate with each other, we need a set of laws, we need a set of protection, we need this like this kind of common structure, uniform structure of safety that enables communication. And it's actually very similar to, for example, Nick Srnicek's definition of a platform. Like, what does he say? So a platform is basically a thing that enables communication between many people by like providing some maybe technical limitation. It's not the way I will define platform. I don't want to spoil anything, but I think it's we can say that Hobbes and then Schmidt were very like proto platform, not capitalist platform thinkers.
I was thinking about like really quickly this like the way Benjamin Bratton goes draws from Schmidt, which is kind of funny because like Schmidt hates technology, but the way he does it is basically by connecting the idea of decision, which is not really about like, it doesn't use that much of political. It's much more a book about like design, platform design. He thinks of it as design and decision, and then it's like it's not even necessarily like decision, but decision is already like embedded in all of those structures that are determining each other, right?
Yeah, so every platform that we know has a kind of outside, you know, we can say like, I know there is a cloud platform, which means that, you know, there is non-cloud, right? This kind of and like things that don't not on cloud, they kind of like have a very different mode of existence, and that's the Schmittian Hobbesian act here, right? And for Benjamin, he clearly wants to find a structure of sovereignty here. Jesse, you were talking about political romanticism. Okay. Okay. So yeah. So and Bratton looks for a structure of for sovereignty because I mean there is also Parisi who's trying to reinvent decisionism. How was this article called? Like it's all a very romantic question, you know, of decision. Decision is a romantic term. It comes from Kierkegaard, right? And it's like this moment of decision and how it is related to order of things. It is a very important question for this kind of determinist world. So yeah, and like at the same time, like when for example, I don't know, Nick Land talks about decision and Bitcoin, it's not actually clear if that's a good parallel term, you know, because we have like things like decision algorithms, but it's not Kierkegaard decision, right? But at the same time, there is something here, right? So can we recover this kind of voluntaristic way of looking at things? Maybe. Yeah. But yeah, it's clear. I think for Bratton, the political stake here is to find sovereignty because he wants to find freedom of will, some kind of our agency in all of this stacked world. But I think one important point here is that already defining world in a particular way, like when you say world is a stack. I don't think we're going to read Bratton in this seminar, but I think you know what it's not actually a technical metaphor. It's a stack, but a real stack doesn't work exactly in the same way. No, I think for Bratton, actively uses his, Artemis said on chat that for Bratton, cloud is outside. It's my understanding of reading Bratton that he retroactively imposes his tech metaphor on kind of everything before in a way of becoming, right? So maybe like everything always wanted to be part of tech, right? And the city is already part of it, and government is already part of it. Right, and but I'm saying, you know, this kind of act of theoretical decision of imposing this kind of particular order on things is also very voluntaristic, and I don't know. We're going really into moral philosophy here, but you know, all of us thinking, you know, and Heidegger and with his criticism of technology, and Carl Schmitt with his notion of sovereignty of decision, and as if they come from, like, I think one of the most important genealogies of this for me is from Kierkegaard and his concept of decision. And I think one of the most weird but also interesting ways in which this whole thing was criticized was by Walter Benjamin, who was also a staunch Kierkegaardian, but he tried to, I think his idea was that you know, there is no such thing as a decision. Like, there is no such thing as a decision in the real world. You cannot just kind of make some kind of decision like in Kierkegaardian terms, because everything is determined. You're always part of some kind of law. He talks about Goethe's book Elective Affinities, that, you know, there is a kind of geometric law of attraction of two couples, which led them to a really sad situation, right? But then he says that the real moment of kind of tragic truth and tragic freedom is when you make some kind of tragic speech in the end, when you like in a tragedy, you have this moment when you just have a monologue, and this monologue is related to the fact that you made a very bad decision and everything just went wrong with your life. But it's also, it's kind of compensated because it is the actual moment of freedom. So let's, you know, if you want to look at kind of role of find a place for freedom of will here, I think theory is the best place for it, because I think theoretical work is this kind of like exercise. But at the same time, I want this theoretical work to be put back and influence my practice. And that's why, you know, we're talking about algorithms and not Carl Schmitt. Okay.
I think there's if I could quickly say something, I think there was a paper a couple of years back, and now he's going to put a book out as well, by Bernhard Rieder, who looks at how to consider algorithms, or if we say any technologies of automation, as an actual subject of analysis for the kind of work that you're interested, or that I guess mostly we are all interested in. So he, I think the book that's coming out is called Engines of Order, and basically what he looks at is both the algorithm as being capable of producing an interested reading, so that it has a certain material socio-historical lineage that, for example, the Bayes classifier, which is an example that he uses, is a way of perceiving a datafied world, basically, and to order information. But then at the same time, this kind of like general algorithmic technique is always implemented in an actual system, right? So there's never the algorithm on its own, which I think is where so much of the theoretical work falls short, by just thinking about the algorithm as opposed to all the other components that are part and parcel, and the other like human technology relations that are part and parcel of actually setting up any workable system that has any effect. So he's thinking about, on the one hand, the actual social historical lineage of the algorithm being capable of producing an interested reading, and on the other hand, the social material conditions into which it is integrated, and then how automation kind of takes shape in it. So I think I can definitely recommend the article. I think it's called Scrutinizing an Algorithm. I can put the link in the chat.
Thank you.
Yeah, that would be great if you can do it.
So yeah, so if I heard this correctly, I think it's kind of similar to Marx's argument that, you know, there is this kind of in machinic fragment that there's some kind of current contemporary social knowledge, like scientific knowledge, that is for good of humanity, but, you know, the current situation in which it is implemented as fixed capital is always in a very interested way, which has to be subsequently liberated, right? Yeah, it's interesting, and yeah, I mean, so algorithm produces some science that need interpretation. You interpret them in business terms, but it's not even interestedness or disinterestedness as much as a kind of complete meaninglessness of it. At the same time, as we will see, you know, ontology of algorithm is not just a system where is like this kind of system evolves in a life manner, you know, as you said, by all the participants, and we will see, you know, how we will, like, that's why we're not reading code all the time. We will actually look at organizations which implement algorithms and work on them and work data for them to understand how they evolve and how they actually exist in a material sense. Yeah, and you can, yeah, it's very easy to inscribe interestedness in this bigger structure. However, you know, what could be the ontology of this entity that that has this, like, you know, so we have these organizations that have employed computer systems and people and some kind of media images to work in this kind of manner, and we cannot really reduce this ontology to, for example, legal term of business or organization. You know, there is kind of entity that survives there, that, you know, you can, like, there's all these different ways to exist in this world. Like, for example, there was this news a few days ago that the first CGI actress was signed to Actors Guild of America, I think. Have you heard of it? So they made a, like, completely 3D actress, as they have this kind of firm that operates her, probably evolves her, and then she's signed as an actress into Actors Guild, I think. Right. So what kind of existence is it? It has media image as a kind of important part. It has computer system as another important part, but part that can and will be changed and maybe swapped. They have kind of legal department which figures out a way to make sure it kind of works in economy. All of these, like, entities, they work together is, I think, like, the best way to say, what is it, a body without organs, right? Because every particular component is not necessarily the most important of it, but there is a kind of total sum of intensities, right? Like, the whole thing kind of holds together by being like something independent. I don't know. Yeah, so that I think is like what we can, like, what kind of entities we are dealing with here, and with, like, different platforms in a general, understood in a generalized way, will help us highlight, you know, this, how this kind of contemporary existence is defined by, like, in very different modes, which are necessary in very different respects.
Valentin, thanks for this. Should we maybe use this last 5 minutes for some housekeeping tasks, etc.? So everyone that is taking this seminar for credits, but ideally everyone that's taking the seminar should do a presentation or on some of the readings or whatever we are doing that week. It might not always be readings, as we saw this time with the game. So Valentin and I thought that the easiest way to do this is to just send out a Google Doc with all the available readings or slots, and then people can sign up. But maybe we could already, if there's some volunteers that could do it next week, so we have this sorted out and then we can go from there. Or if that doesn't work, we can also just, I don't know if everybody got syllabus, but as Valentin mentioned already in the seminar, next time we are gonna look at Stratechery, the blog, and then the Melvin E. Conway's How Do Committees Invent? So if there's people that would like to present on either of those texts, that would be fantastic. I don't know if everyone is aware of how these presentations work, but it's basically just a brief critical comment of what you've read or whatever, consumed that week.
So this is in Google Drive.
Yeah. Yeah.
I think the question is, does anyone want to make a presentation either on Amazon or on Conway's Law?
Exactly, that is the question.
And we can decide now or in the chat later. So we will have it in a structured manner. But for for each of those 8 sessions, somebody will make presentation on the text we read.
Okay, Nikki just said that she can do Conway. Great, I will put that down. Is there anyone that would maybe?
Somebody mentioned Amazon, so maybe there's a
yeah. Who mentioned Amazon? Okay, so we have both covered. Great. And then for further presentations, we're gonna circulate this Google Doc.
Okay.
So any last words for this first session? Or
okay, thank you so much, everyone. I hope it was meaningful, and I'm looking forward to the preceding steps on our path.
Thanks a lot.
Thank you.
Daryl, I'm gonna send you the syllabus again if you don't have it. Okay. Thank you.
Could you send me the syllabus again too?
What did you say? Could I?
The syllabus. The syllabus. I don't know that
I will do that. Yeah.
All right. Great. Thank you.
Cool.